Fisher titration. We shall go through an overview on FTIR first. Firstly, the basic principle of IR spectroscopy. Generally, all atoms in organic molecules are in continuous vibrations and rotations with respect to one another. In IR, electromagnetic radiation with a wavelength ranging between 800 to 15,000 nanometer is passed through the test sample. Do note that the wavelength range of 800 to 15,000 nanometer is the normal wavelength range that falls under the IR region. When the frequency of a specific bond vibration equals to the frequency of the IR radiation directed to the molecule will absorb the electromagnetic radiation, and the radiation is then converted into energy of molecular vibration. This will cause the bonds in the molecule to stretch or bend. Note that the wavelength of the radiation absorbed is characteristic of the bond that absorbed the radiation. The degree of radiation absorbed by the bonds can be measured and detected in IR spectroscopy. This is how a typical IR spectrum will look like. The y-axis is labeled as percentage transmittance and the x-axis is labeled as wave number. Percentage transmittance indicates how much radiation passes through the sample. Percentage transmittance is inversely proportional to the amount of radiation absorbed by the molecules. For example, if the sample absorbs high amount of radiation at a particular wavelength, very little of the radiation will pass through the sample. This will therefore give rise to low percentage transmittance for that particular wavelength. If the sample do not absorb any radiation at a particular wavelength, all the radiation will pass through the sample, giving rise to 100% transmittance. Wave number is given by the formula 1 divided by wavelength, and the unit for the wave number is cm to the power of -1. Do note that different functional groups and bonds have characteristic absorption bands in the IR spectrum, and this is independent of the other functional groups and bonds in the same chemical structure. Important point to note for all students: you will need to refer to textbooks or other references for the list of characteristic IR absorption peaks for common functional groups. For example, if I were to give you this IR spectrum, you should observe a trough between 1690 to 1760 cm-1 wave number, and you should notice here that the percentage transmittance is very low. So what does this tell you? Firstly, a trough between 1690 to 1760 cm-1 wave number indicates that the sample absorbed radiation in this wavelength region. Secondly, the low percentage transmittance indicates that the intensity of radiation absorbed is strong. Hence, if you were to perform a quick research, you will identify that C double bond O bonds found in ketones, esters, or carboxylic acids absorbs radiation at a region between 1690 to 1760 cm-1 wave number, and the intensity of the absorption is described as strong. With this information, it will suggest to you that there is a C double bond O in the test sample. FTIR analysis involves the following steps. Firstly, sample preparation, followed by the introduction of the sample into the FTIR instrument and generating the IR spectrum. And lastly, interpreting the IR spectrum obtained from the analysis. As mentioned previously, students are required to use the IR spectrum results obtained and the available references to assign the major peaks to the corresponding functional groups of bonds, and if you know the structure of the compound, the results obtained can be used to confirm the identity of the given test sample. Please refer to the video on the lab demonstration on how to perform FTIR analysis. Hi guys, this is a video demonstration on FTIR sample preparation and analysis. First of all, these are the materials required for the preparation of sample discs. You will need a mortar and pestle. The mortar and pestle is porcelain, hence please handle them with care and do not scratch or drop it. Next, you will also need potassium bromide or KBr powder. This is required for the preparation of the sample disc. You will also need the test sample. To prepare the KBr disc, this is the apparatus that you will need. First, the lower cylinder, the upper cylinder, the frame, or sometimes referred to the O-ring. Next is the pellet remover and the pellet remover base. Finally is the pellet holder where your KBr disc will be placed on for analysis. You will also need the hand press during the preparation of the disc. Now we will show you a demonstration on the steps to prepare the sample. Using a spatula, transfer about 15 mg of KBr powder into the mortar. Note that the KBr powder is hygroscopic, hence, please close the bottle tightly after use. Next, using a smaller spatula, transfer about 1 mg of test sample into the mortar. Using the pestle, grind the mixture thoroughly using a circular hand motion and ensure that the mixture is fine and homogeneous. Next, assemble the lower cylinder and the frame together. Transfer the ground powder into the cavity in the frame. Ensure that the cavity is completely filled with the powder and the powder is level. Remove any excess powder on the surface of the frame, if any, with using the Kim wipes. Next, fix the upper cylinder. This is how the final setup of the lower cylinder, frame, and upper cylinder will look like. Place the assembled setup onto the hand press. Pull the handle and press the handle down. You need to apply sufficient strength for about 1 to 2 minutes in order for the disc to form properly. Then, use the pellet remover base and the pellet remover to remove the frame from the cylinders. This is how the frame with the sample disc should look like. Next, attach the frame to the pellet holder. Now we shall proceed to the FTIR instrumentation. Switch on the computer, printer, and the instrument. Click on the program known as IR Solution. This is how the program display looks like. You will need to wait for a few minutes for the instrument to warm up. Before starting the analysis, check to ensure that there is no sample in the instrument left behind from previous experiments. To perform the analysis, first, you will need to perform a background scan. The purpose of doing the background scan is to remove any background signal which may otherwise affect the analysis of the test sample signal. To perform a background scan, press the BKG button. Click OK. The background scan spectrum will then appear on the screen. Next, place the pallet holder containing your test sample into the sample compartment and close the compartment. To start sample analysis, click on the Measure button. Enter the sample description in the comments box. Then click the Sample button. The IR spectrum for the test sample will be displayed on the screen. To assign the peaks in the spectrum, click the button Manipulation 1 followed by Peak Table. Enter the parameters of the analysis based on the stipulated requirements. Next, click Calculate, and you should see the wave number of all the peaks in the spectrum. Click OK. To print your results, click Print and select Easy Scan, Template for printing. Collect your printout.